Now you see many sums of APs in example 7. Now look at A. Now A says you want to sum R from 0 to 4k. Now if you can see that this is a sum of an AP group, if you can't, then list them out term by term. You put in R equals to 0, you get 0, put R equals to 1, get 1, and so on until the last term is 4k. Now this is an AP, or the sum of an AP. First term 0, last term 4k. Number of terms, just take the upper limit minus the lower limit plus 1, you get 4k plus 1. So what is the formula for sum of AP? N over 2, first term plus last term. So all you need to do is to sub in all the correct values and then you will have the answer. You look at B. B wants you to do the same thing. You want to sum R from 1 to 2n plus 1. So the only difference now is you have 2n plus 1 at the upper limit. So if you can see that it's an AP group, if you can't see it's a sum of the AP, then just list them down term by term. R is 1, R is 2, R is 3, all the way until the last term, 2n plus 1. Okay, so this is an AP or sum of AP, first term 1, last term 2n plus 1. Total number of terms is upper limit minus lower limit plus 1, and you get 2n plus 1. So that means the sum can be written like this. Okay, try this on your own. You don't have to wait for me to give you the answer. R is 1, 2, 2n plus 1, R. So the formula is again this one. Number of terms, 2n plus 1 over 2. First term, 1. Last term, 2n plus 1. Okay, then you realize that you can simplify the term inside. What do you have inside? You have 2n plus 2. And 2, the 2 inside can cancel the 2 outside. So you have 2n plus 1, n plus 1. Done. Now if you can do A and B, then C is very similar. Now you want to sum 4R from R's 2 to 50. And then one of our earlier properties says that you can take 4 out. So that's why you see the 4 outside. Then if you cannot see that this is a sum of AP, then again just list them out term by term. R is 2, you get 2. R is 3, you get 3. All the way until the upper limit, R is 50. And then this becomes a sum of AP. First term is 2. Okay, your last term is 50. The number of terms is upper limit. Take away the lower limit plus 1, alright, and that's 49. So that means I go back here, I can make use of the AP formula. What's the AP formula again? N over 2, open that bracket, A plus last term, F. So I go over here, 49 over 2, first term 2, sorry, first term 2, plus last term 50. And then I press this out in the calculator, I will have 5096. Now a more direct way will be this. Instead of taking the 4 out, you can tell yourself, alright, I'm going to put 2 in, I get 3. I put 3 in, I get 12. I put 4 in, I get 16, until I put the upper limit in, which is 50, I get 200. Then this is also an AP. The first term is 8. Common difference is 4 if you want to write it down. I don't need that. I can write down the last term with 200. And then the number of terms is again the same. You take the largest number, which is 50, alright, or rather the upper limit, which is 50. Then take away the lower limit plus 1, and this is 49. Alright, then I go back to the AP formula. 49 over 2, first term plus last term. You have same answer. Okay? Now let's take a look at D. Now D says you want to sum 6R plus 5 from R 7 to 20. Now from the properties, I know that I can break the sum into two pieces. Summation 6 r, and the 6 I can take out to form 6 summation r from r 7 to 20 plus summation 5 from r to 20. Now the first piece here is AP. This AP has got first term 7, last term 20, number of terms for upper limit, take away the lower limit plus 1, and that's 14. So that's why you can see the AP formula here, n divided by 2, then first term plus last term. And then over here, this is just 5 times the number of times 5 appears, and that's again the upper limit minus lower limit plus 1. So the answer is 7. Okay? Now some of you might want to use a more direct method. Again, some of you might be able to see that you have AP. First term is 6 times 7 plus 5.7. Last term is 6 times 20 plus 5, 1 to 5. And the number of terms is unchanged, upper limit minus the lower limit plus 1, that's 14. So again, the AP formula, n over 2, first term plus last term, 70 as well. Okay? Now I hope you have tried part E on your own. It's not difficult. Now you want to sum 3 minus 2r from 1 to n. Now what I will do is I will break up the 3 minus 2r. I write it as two different sums. Then the first one is just 3 times n minus the second one. You see an AP there. First term is 1, last term is n, number of terms is n. So that means you apply a formula, you have n over 2, first term plus last term, and then realize that you can simplify this further, without common terms, end up with n, 2 minus n.